halogens deserve special mention when we talk about different directing groups. So halogens, where do they fit in our directing group? So let's go back again to this same resonance form where we show an R group attached to the ring, and our question is, how does that group interact with the carbocation? And why are halogens kind of different? Okay, so halogens actually are like electron donating groups. A lot of our electron donating groups, the atom on the ring had a lone pair, and a halogen, of course, has a lone pair. So you can imagine chlorine being in place of that R group, and that lone pair is important because we can use that lone pair to show a resonance form and help to stabilize our carbocation, which does not have a full octet. How many lone pairs am I going to put on chlorine? I think I'm out of lone pairs. Okay, that's what we want. And so this, you would think a chlorine should provide resonance stabilization. And in fact, you'd be right. There is resonance stabilization. However, halogens, like chlorine, also act like electron withdrawing groups. If we put a chlorine in that position, just as an example, you could also draw bromine there or iodine there. As a highly electronegative atom, there is a really strong inductive withdrawing effect. So there's resonance stabilization I know these big pauses to write words, kind of lame. And then there's inductive destabilization. So what is a halogen? Is it an electron withdrawing group? Is it a withdrawing or a donating group? In fact, it's both. How's that for an unsatisfactory answer? It's both. Actually, halogens are ortho-paradirectors. And you might say, well, if they're ortho-paradirectors, that seals it. They must be donating groups. However, they are not activators. They are actually deactivators. Of course, ortho-paradirectors, that's something that we see in electron donating groups, and deactivators are things that we see in electron withdrawing groups. So we see both this resonance stabilization and inductive destabilization in halogen, which keeps us from putting halogens cleanly into the electron donating or withdrawing groups. They have properties of both. They are, however, ortho-paradirectors, and they also happen to be deactivators.